So performance testing is something that typically happens at an environment later in your development cycle. Think about that QA environment or that environment that looks, tastes, and feels like production but isn't quite production. But the problem is that's typically quite late into the cycle. So by that point, if there's any issues, is it too late to fix them? Well, we're going to be talking all about shifting left your performance tests in this episode of Cloud with Chris. Hello there, welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thank you folks for listening in to this one today. We have got another DevOps related topic. We've had a few of those recently, but again, we've got another really interesting one, actually, a really exciting one. I'm a big fan of performance testing. You'll all know if you've listened to the content before. I'm a big fan of non-functional requirements and making sure we have this requirements-driven engineering. So being able to validate those is a really important part of the process, and we're going to be talking all about that, shifting left performance tests in this episode today. So as usual, if you like the content, please hit like, please hit subscribe, please hit the notification bell if you're listening or watching on YouTube. And of course, many other platforms available, cloudwithchris.com, Apple Podcasts, Google Podcasts, and of course, Spotify as well. So with all that done, it's time for us to go and introduce our guest speaker for the day. So I am very pleased to introduce Hari Krishnan, who is going to be talking all about shifting left performance tests. So without further ado, let's go meet Hari. Hi, Hari. How are you doing?
I'm doing fine, Chris. How are you?
I'm good, thank you. I'm good. Thank you so much for joining. A really interesting topic. Again, it was one of these topics that stood out to me when I was reviewing session proposals, etc. And really excited to talk about this. Really interesting topic.
Glad you liked it.
Awesome. So, best place to start at the very beginning, Hari. Introduce yourself to the listeners.
Sure. So I have a varied experience as a developer, production support engineer, and a multitude of performance-related activities, like wherein I tune architectures. But largely for the past decade, I've been playing this role called cloud transformation coach, which essentially involves shifting monolithic on-prem applications to the cloud, as well as guiding teams build greenfield applications on the cloud, like with 12-factor applications and whatnot. So, but all through this process, an aspect that I've been noticing so far is the performance testing, and that area is fairly similar, and nothing has changed in that area, even though we made leaps and bounds progress in the rest of the field. So that's what inspired me to bring this topic to the proposal, and I think I should have the experience to share. And also through the conversation with you, I hope to learn in terms of how we could potentially change this around and shift left the performance.
Excellent. I think that's a really nice segue into the content, right? So maybe let's, I guess, ground in some of the context of why this is important first and talk a bit about the problem.
Absolutely. So I do have some slides help with the conversation. So let's jump right into that. So to begin with the context, I probably will ask you a question, Chris. This environment, do you find your performance issues? So that.
Yeah. I'm hoping that if anyone's playing along whilst listening in and watching, they're not answering with production, because that is the wrong answer. I guess typically there's some kind of UAT or integration environment, or a dedicated environment for perf testing on that line to production is what I'd say I commonly see.
Absolutely. That's been my experience as well. So most of the teams I work with usually start identifying one or two performance issues on staging, because that's where you at least have like a couple of users to talk about any of these problems. Right? And prod replica is where I see a lot of these issues being replicated, of course, because the infrastructure is very similar to production, and that seems to have merit, of course. And for those issues that we don't find, our users identified for us, then we need to fix them.
Yep.
And that's not a good place to be.
Absolutely.
Right. And the intensity of the red color here kind of indicates the cycle time for resolution. So as it shifts to the right, it becomes worse.
Yep.
And that's not desirable here, the mean time to resolution. So that's not a good place to be, right, in terms of the graph.
Yeah.
So I'm just wondering why this happened, right? That's when I did a quick, situation awareness sort of slide, right? Which is what is typically the performance testing. So a developer writes code and she pushes it onto the development environment, goes to staging, and then that's when probably the first time the performance tester comes in, sets up the test script, the load agent, generate load, send the load to staging, maybe even do some testing on production, then generate reports out of it, share it with the dev team, they analyze it, and then that's the cycle. That's the typical cycle there.
Yep.
What's the issue with setup? What I've noticed is people identifying performance issues in staging of production is actually quite late. And the difficulty with identifying it that late is the cycle time is compounding effect.
Yes.
It has to go through the same promotion process for a build, and that's not very good. And I'm typically not the only engineer trying to fix my issues. So there are higher environments like other developers might also be wanting to test their performance improvements.
Yes.
So we have to go the time sharing, and that's also very difficult. And that's what leads us to this situation. What is desirable is this, wherein we shift bulk of the performance issues identified to the left, right, on the local machine. And of course, there are those few issues which do require us to test it in production. For those, we cannot do away with that part. But what I'd like to do is shift a bulk of it to the left. That's the whole context of this whole topic.
Absolutely. And I think just in case anyone is new to the whole shift left kind of topic for a moment, I guess what we're talking about there is there's this whole end-to-end developer lifecycle where you commit code, you might do it in branches, for example, that aren't production feature branches, etc. And the idea is that you want to put your testing into that process and shift left in that development cycle. So you're finding those things earlier, as you rightly pointed out, those issues that fester and stay and are there in the production environments are typically those ones that probably could have been prevented and caught quite easily if you had that efficient testing in the earlier stages. But the problem is, because you've had releases and releases and releases going on, you don't know that actually what was the change that caused that thing to go wrong. So what was the exact change? And you're starting to find that needle in the haystack, but what haystack do you even look into? And that's the problem Shift Left is trying to solve, isn't it?
Absolutely. That's a great, explanation also for the environment. And that's what I'm trying to represent in the diagram, wherein the left is your machine and the extreme right of production right. So, of course, your mileage varies in terms of how many environments you have in between. But
sure.
That's the topic.
Excellent. Good.
That should be easy, right? Like we should shift left. We already have a performance test set up on higher environment. So all I need to do as a developer is where the performance test is at, borrow the first test setup, start running performance, scripts on my local machine in development. It's easier said than done. So it's a lot of difficulty, right? Let's look at the challenges of shifting left before we even say it's good to say we shift left, but it's not easy. That's why it's not being done.
Sure.
So the first one is the scale challenge. You have a higher environment which is fairly sophisticated, and how do I create a realistic representative environment on my laptop, which I can say, okay, if I test it here, then it works there. How do I create that correlation? First, of course, the sophistication of the architecture is this. We have a hybrid cloud, multi-cloud environment and production and cloud replica. Staging may have a slightly less complicated setup. And by the time you reach the local machine, it's just a humble laptop. Now, obviously, this does not equate in any manner to, how do I say that something runs here will run in the higher environment. It's the same for your network topology as well. Firewalls and the latency levels and You can replicate it to an extent. You have tools to do that these days, but then it's not realistic, right? And the performance setup themselves tend to be fairly sophisticated these days. Multiple machines, because you need to generate a ton of load, and trying to put that server farm kind of setup into my local machine. This is what happened to my laptop. Memory just shot through the roof, and that's not desirable either.
And that's a really interesting point there, just to jump in there, Harry, because the point of running these tests is you want to understand, is the system capable, back to something I mentioned in the beginning, is the system capable of meeting those non-functional requirements that you have? So if the environment isn't configured in the same way as production, well, how do you know production is actually going to be able to deal with that? What assumptions are you making if the environment is different? If the tests themselves can't meet the production level demand, again, how have you proved the fact that it gets to that level? But then this is almost the worst of both worlds, right? Is you're running it on a machine which doesn't give you that environment, but you've also got the load tests which are running on that machine where the workload is running, so probably impacting, because of the contention of the resources, impacting what is running. And you've got this very bottlenecked system then of trying to load test something. It's trying to serve up the requests, and you can't make any conclusions from that then. It's a really interesting problem.
Precisely. It leads to a lot of false positives, and we tend to waste a lot of time trying to get that whole setup running on 16 GB machine. Not desirable. So what do we do about it? So the lesson that I took away early on in my career is, anytime we have to solve this, we have to scale down. It's impossible to take every design phase to the C trial, right? It's impractical. So that said, it's not easy to scale down either. There has to be some basis of scaling down, right? Like I have, let's for a moment consider these two KPIs. The response time and request per second. Throughput and latency are the most sought after sort of holy grail metrics. Do I scale it with aspect ratio, saying, I will, give a tolerance level because it's running on my local machine? Or do I give tolerance only on a certain parameter? There's no scientific reasoning to this, right? And I just took two parameters, and that's quite complicated in itself. Now, there are a multitude of parameters I need to take into account while scaling down.
Sure.
So what is the accurate way to scale down and still be able to validate the KPIs? So this is a question that's been pestering in many of my colleagues' minds also. The answer to this is the hard part, which is like not possible. There is no scientific way to do this, right? Because my machine does not equate in any manner to a server grade processor in memory.
Yep.
So all is not lost though. We can still scale down, but we cannot scale the problem. We can scale the trend and invalidate the hypothesis. So I sort of threw into jargon there. Let me quickly clarify what I mean by invalidating the hypothesis before going to scaling down the trend.
Yeah.
Okay. So what would be a hypothesis? It's very much something that we are all familiar with from our school days. The statement we make, and it could be true, it could be false, and that's the whole power of it, right? The hypothesis has a verifiability aspect and a falsifiability aspect. So just to take a very simplistic example, if I have to make a hypothesis that all green apples are sour, and prove that, there's one way which I could go eat all the green apples in the world, not scalable. Or I could say, I find one green apple with sweet, and that disproves the entire hypothesis. So sort of taking that simplistic aspect and applying it to software engineering and performance testing in particular, what I realized is if you could have a big problem, you can scale down the trend and disprove it. So let me just share an example. So recently I was dealing with this kind of a situation wherein I was tasked with building a system that has degradation of response time at logarithmic scale when the throughput is increasing at exponential scale. Sort of 10,000 RPS is not something I can test on my local machine.
Yeah.
Instead, you just don't have to degrade so bad, but when there are traffic spikes, I don't want it to degrade in terms of exponential. This is not something I can test on my laptop. What can I do? How do I scale it down? So there's a clue in this problem, right? Which is I just want the trend, which is to degrade logarithmically rather than exponentially.
Mhm.
So I take that and I say, probably I can't do 10,000 RPS. Maybe I'll do 1, 10, and 100 and then try it out on my local machine. And I realize it doesn't work. It already has that, exponential response time degradation. So immediately I realize there's a problem
Yeah.
even on my local machine. This thing off, which means I have disproved the hypothesis. So the proving hypothesis part would have been the actual production run. Now I've disproved it by scaling down the problem. So thereby I don't need to go to the higher environment this time. I've tested it on my local and I try to fix it on my local itself. Yeah. And once that is done, and I realize that my code improvements have helped me achieve better performance now, should I actually push this out for production? Not necessarily, right? It's inconclusive.
Mhm.
How do I say that because it's working on my local machine at 100 RPS, it doesn't mean it works at 10,000 RPS. However, I have ironed out that one issue wherein I did not have to go all the way to production and realize that it doesn't even work at 100 RPS.
Mm.
So to validate the inconclusive hypothesis, I need to do the verification part now, for which I do it at a full scale test. And I realize I can still track at the same logarithmic scale for 1000 RPS, but maybe beyond that it falls off. But that's okay. One issue I solved on my local machine. The other issue, slightly longer cycle time, I can still, figure out by coming back to my local machine, make improvements, again, test it out, and move forward. So the moral of this story, at least for me personally, was on the left-hand side, we learn through falsifiability, and on the right, we confirm our learning through verifiability. Does that make sense? I mean, just wanted to.
Makes complete sense, and I love the idea in there that we often hear about iterating over our code development, for example. We hear iterating over unit tests and integration tests and changing those functionalities and tests as we change the functionality if it makes sense, if we're fundamentally changing what we're testing. But you don't often hear people talk about this. You don't often hear people talk about, right, we need to start almost, what's that analogy? How do you, basically taking chunks one out at a time anyway. I forget the analogy.
Right.
And this is the same idea, isn't it? That actually you don't need to go to that extreme end of the scale and try and understand, does it meet the end need? But as you say, start looking at the trends, and it's almost looking, it's making me reminisce a bit back to the days of when I used to do statistics and these things for studying, etc. And it's exactly that, is looking at those trends and those statistics and going, right, what is the trend that we're seeing? Let's prove our hypothesis and look at this statistically. Looking at getting a significant statistical value and output of that, and then going, okay, we can't conclude that it does what we need to do here, but we at least can validate that actually the trends we're seeing so far measure this. And I love that very scientific and incremental approach, is almost bringing that statistical and DevOps mindset to performance testing. It's a really interesting idea.
Absolutely. And as you rightly pointed out, the important piece here is to differentiate the problem into its component equations and disprove it on the left-hand side.
Yep.
If you cannot prove it, at least you can disprove it.
Yep.
And then move. So that's the scientific aspect, and that's what I find interesting about this approach. There's probably just one more example I'd like to give in terms of how we can scale down.
Sure.
So this is one of my favorites, with and without experiment, A or B, A and B test.
Mm-hmm.
So let's say I have this imaginary problem where I'm currently hitting 10,000 RPS at 80% CPU without cache. And when I add a cache, I'm expected to hit 1 mil RPS. Very ambitious, but I'd like to see if it's even possible to test on my machine. 10,000 RPS itself was out of bounds. 1 mil is not something I can test on my machine.
Sure.
But what can I do? So let's say on my local laptop, I hit certain X RPS, request per second, at a certain max CPU. So any number, 60%, 70%. And with the cache, when I introduce the cache, I hit a Y RPS. And again, it doesn't, I just make sure that the CPU level is the same as what I did on my previous run. It's an apple-to-apple comparison on my local machine. The only thing that matters now is that adding a cache actually had this improvement at least X has to be less than Y. Otherwise, the cache is not adding any value. So many a times I've seen in production that a cache exists, but it's not being configured properly. So it's just existing there as moral support, not essentially doing anything worthwhile. So at least with my team, I encourage developers to say, hey, you're introducing a new component into the system. At least verify it makes a difference on your machine. So that way you know you've configured something. And if that's a miss, then you don't even go to the higher environment. You can just fix things right there on your machine.
Yeah, really, really interesting idea again, because what you're doing there is you're trying to control the boundaries of the experiments and the tests that you're running there. Because, if you're thinking about a cloud environment, 80% CPU, for example, there, it's fairly easy in that environment to control that because you just scale based on a 80% CPU percentage. So when you reach that threshold, you add a new instance and you keep scaling and scaling on that way. But in a local laptop, you don't have that luxury of saying, right, I'm going to cap my usage at 80% CPU here. You've got to try and max it out, as you say. And that analogy of being able to work within the boundaries of what you can control, which is the max CPU usage, as you rightly say there, and then being able to go and effectively look for the delta. Hey, is X less than Y across both of these tests? Are we seeing that in a significant way? Again, thinking back to the scientific and statistical side of it, makes complete sense. I think the important point, though, as well, in that aspect on the left-hand side, is also making sure that you're conducting those tests fairly. I sound like a statistician now, it's great. Which is about making sure you don't have, I don't know, a virus scanner or something else that might be eating into that CPU, for example. You need to make sure that that environment is going to be tested fairly across those different runs there as well.
Absolutely. So the whole point is making a full circle. There's no scientific way to scale down the problem, but like you rightly pointed, you can create boundaries within which you operate, which you can control. Being scientific is all about controlling variables. You just have one or two variables changing. Everything else is a constant. So thereby you are able to associate causality, so to speak.
Yeah, because it's really interesting. Even if you and I compared our results, for example, right? I have sat under my desk a gaming PC, which I've gradually been building over time. The results that I get on that will be very different to what you get on your laptop, which is built for portability, etc. So again, it's being careful about the nuances of how you compare those results, isn't it? I think.
Absolutely correct.
Interesting.
All right. The next one is slightly in terms of how we work with performance testing. This is called a capacity challenge in terms of whether you have people to work on performance testing and how that fits into your sprints or iterations and whatnot, your style of turning off pieces. Let's say you have 3 sprints and a developer is starting to work on feature number 1. We as a team know, I'm just imaginarily speaking, that feature 1 testing it is going to be quite time consuming. So performance test, you got to siphon it out as a separate task. I hand it over to the performance tester, and as a developer, she moves on to the next feature, and that is also handed over to the performance tester. And now we cover to sprint number 2, and we start running feature 3. And now the performance tester comes back saying, "Hey, I have some feedback. I realize it's not meeting the NFR, so I would like to show this to you. But sorry, we cannot take that up now because we already committed to sprint 2.
Yep.
I need to start with number 4. And by then, there is more feedback on feature 2 on performance area. And by the time we reach sprint 3, it's fixing performance issues for 1 and 2.
Yep.
And the first tester is now looking at feature 3, putting it to a stage.
Yep.
Practically so what? Right? So, and this is what is an anti-pattern. It's quite often seen in teams called a hardening sprint, wherein we are able to chug along very quickly for a few sprints, and then we say, "Hey, I have technical debt, I have performance issues, I can't take up features now. I need to solve it." This is not something new. We've already seen this problem, right? Whenever we call a feature done before the testing is complete, it always comes back to bite us.
Yep.
It's a typical example of the sprint cadence and how performance testing being siphoned off is never a good idea. So, how do we resolve this? So, first thing, according to me, is collaboration between the perf tester and developer. I mean, those two roles, I find it even hard to separate it out really, because of course the expertise part is important. Some people are really good at understanding the KPIs and setting up the rigs and whatnot. That's a specialty that definitely holds some merit. But as said, the developer also has to have a significant input into how features put through spaces. So the collaboration aspect. Second is coming to terms with the fact that it does take you 2 sprints almost in this scenario to take a feature, build it, do the performance test, get the feedback, incorporate it into your code, and then again retest it. In the best case itself is a 2-sprint long duration. The only way to resolve it, of course, is shrink the largest bit here, right? This is the performance test. So to me, it's all about reducing effort, complexity, repetition, and automate everything about performance. That's personally my take on solving it. But of course, the first bit is realize that yes, it does take this much time and come to terms with it, and rather than say features done, performance is pending, so we should.
Yeah, it's interesting. It's gotten me thinking about how do you control that and how do you optimize for that as well. It's an interesting challenge because you don't want to cut those tests too short and not get those conclusive results that you're looking for either. So again, there's that challenge, isn't there, about balance between the two there.
Right. So one extreme is you have a long running feature because the performance test is not complete.
Yep.
And the other is the other extreme is to not run the performance test. I think both those extremes are not a good idea.
Indeed.
You do want it complete. That's what I feel. The elimination of issues towards the left. At least the parts that can be tested on the left-hand side can be brought within the sprint. And for those pieces which do need to be tested on higher environments, those can be deferred. There's no black or white. You just have to be in the gray and realize what makes sense. But at least I think it is important to sort of be cognizant of the fact that yes, at least we should eliminate issues we can quickly solve on our local machine. So that's the whole idea.
And it's interesting, right? It also brings the question up of knowing, and this sounds really philosophical now, but knowing what a performance issue is, because if you don't know your baselines, if you don't know how the solution has performed on previous runs as well, how do you know a change has been introduced? Even if you look at that very controlled view in that small environment, and you figure out a way to consolidate those tests, how do you know whether there's an impact or not? Coming back to your point about controlling that environment a bit earlier. So I think baselining and making sure that you have that comparison view as well is really key, isn't it?
Yeah, that's an absolutely important point. In fact, I think so far what I've spoken does not even cover it. I'm practically speaking about new features being turned off, but the important point you brought up there is how do we realize if a new feature is impacting the performance of an existing feature? Do we have a baseline? And the reality is many teams I've worked with don't necessarily have baselines, which means they don't even know if we are worse or better than yesterday. Which is where we need this automation around performance testing, which runs within your CI or whatnot to at least give you certain metrics, which you can then leverage to say, hey, something has happened around this time, and that's practically going back to the finding the needle in the haystack, which is how do you associate which issue introduced a lag in the overall response time. Absolutely important. So for me, just how do you reduce the repetition to reduce the block there in terms of chunk of time that it's taking? One realization I've had is we seem to be repeating how we beta test scripts. The developer writes API test, the performance tester writes perf test script. Both of these generally the only thing they do is generate requests. An API test or a perf test is practically request generation. The difference is in what is the assertion. As a developer, I might look into the response and the values and whatnot based on my features, etc. But as a performance tester, I'm not really worried about the exact values, but I'm worried about whether I'm getting a 200 or a non 200.
Yep.
So that's probably taking API testing as a an ambit to explain this whole area.
Sure.
When there's duplication, it's a bad idea, right? Like one example I can give you is in a project where I was working. The developers were writing API tests in Karate, and the perf testers were writing perf test scripts in Gatling, and of course the Scala test script. So both of these people would write the same test script over and over again, and with duplication, the twin evil is inconsistency. So as the code changes, the API tests also are going out of sync, and perf test scripts are also going out of sync. There's a maintenance nightmare. And then there's a disconnect. Like I said, the developer needs to have input into how a perf test is designed. As a perf tester, I always felt I need to know the architecture before I can poke a hole into it. Having these two separated, sometimes there can be issues that slip through the cracks.
Yep.
Because I don't know the architecture. That's one of the ways to reduce the repetition.
It's really interesting. Like, this brings me parallels of like things like penetration testing, for example, and security testing, where again you need to have that context of the architecture, that understanding. We hear about DevSecOps all the time, of course, and the idea of integrating security in. It's almost like DevPerfOps, isn't it? And I know typically performance testing is included as one of those buckets, but it really is almost a discipline within those different pillars of DevOps. It's a really, really interesting thought.
All right. So let's look at how this can be resolved. Right? For me, shift left means repurposing. So if I have an API test, I would repurpose them as performance tests. It's like you take a perfectly good road car and chop it up and make it go rally. So it has multiple advantages. Of course, like I said, when you have the same test running as API test and performance test, you don't have twin maintenance costs, you have single maintenance. And of course, as a byproduct, it is consistent. And also, there's a coordinated effort between the developer and the performance tester. It's important that they both have a mind share through that test script, and they have that discussion about architecture and what they're testing and how what the feature is about. And having that API test as a common ground promotes that collaborative culture in the team is something that I have sort of learned through experience by reusing API tests as well. It could be done in other areas also, but at least with API testing, I've been extensively, re-leveraging it as process. The second bit is about complexity. So this is fairly interesting slide. It speaks about the ecosystem as a whole, right? I think I've not done justice to the slide in terms of how many icons I have here and how many logos. There are a ton of them, and most of these tools are actually really, really good, and they have their own strengths. So this points of choice when choosing a tool. And once you have the tool chosen, then you need some sort of a metric flow, because just looking at perf test reports in isolation doesn't help. We do want to bring the application metrics alongside so that they can see side by side and associate the load with application behavior characteristics. Once you have metrics, then you need to visualize it. So you need something like a Grafana or a Kibana that adds more complexity. And ultimately, you need the tooling, infra, instrumentation, orchestration. Like you rightly pointed out, the perf pieces.
Yep.
I have to put this whole thing together. Add to that the cost of licensing, which you need to consider, the cost of reference, and multiple other constraints. Eventually, you come up with something fairly unique in terms of what the perf test act itself looks like. And in my experience, even within a single organization, each team has a different stack for testing. And especially with microservices, that's like become a whole different ballgame where each service has a different way of being tested, not desirable. This is hard for the performance tester himself or herself to push into a higher environment, a staging or a non-functional testing environment. Now, having that go into a developer's laptop, if I'm a newbie to any of these tools, I wouldn't know how to get this whole thing set up, and that itself is a big time sink. And I just feel this whole complexity is like sort of eating into the time and also not necessarily providing a lot of good feedback. So that's one area which needs to be resolved. So a way to sort of think of it is whenever you have this kind of fragmentation, the immediate answer that comes to my mind is containerization. So what if I could take a puff test setup and containerize it so that I can just share it with, like, I've built something on my machine to test it. And like you said, you have a gaming PC. And I should be able to give you this package. And you should just be able to say Docker up and have that running on your machine in no time and start testing the service. Just like you have unit tests. You clone the code and you start running the test. And that's how perf test stacks should also be there. And that's where we felt perf test stacks are built differently. Traditionally, what we do is we build a perf test stack in the higher environment and then try to bring it to our lower environment. Sometimes it does not fit. What if we actually built it on our dev laptop and then promoted it like every other piece of code up the environment? It'd be easier to have it running on our local machines as well as on higher environments. So that's the containerization. Does that make sense in terms of reducing the complexity of the stack?
Yeah, it makes complete sense, and I think the thing that it gives you as well, that the whole promise that we get with containers is the fact that we can easily run them anywhere in that consistent environment. So if you did need to run it on a local development machine or in that production environment or staging environment, as you say, that progression towards those later environments then becomes a lot easier because you know the dependencies, all of the dependencies are shipped within that same drop effectively. So you're not getting that delta or any unexplained reasons, let's say, that might impact why you're getting different results across those environments. Then you can rely upon the fact that, assuming the infrastructure underlying it is configured in the same way, of course, there's always a reason that could change different results, but the thing that you're trying to control and make sure is consistent. So it makes complete sense.
Awesome. And in fact, like you pointed out, the stack itself, right, it needs to be able to work consistently across the board. A very good example of that is even performance test tools themselves need tuning in terms of how many threads they generate and whatnot. I've very often seen like one developer having no problem running it because she went and tweaked something and it's now generating a ton of load. But I am struggling with generating even 10 RPS because I forgot to increase the number of threads.
Right.
So such issues could easily be resolved like what you mentioned. So embodying all of that we spoke about, some of us thought, why don't we open source this knowledge and codify what we have seen so far. So I have a very quick demo within 5 minutes to show something in terms of code instead of just going through slides. So we built a tool called Puffy. What is it? It's just a tool which helps you, promote collaboration between perf testers and developers. It's built on top of Karate, which leverages the API test. Then we have Gatling through Karate Gatling integration. We're able to reuse the API test as perf test. And we use Prometheus as metrics though. And ultimately that's visualized through Grafana. This is I'm not saying this is the best stack to use for performance testing, but this is the stack that we commonly use for multiple projects. So we thought, why don't we just box it into a container and see if we can have other people use it. And that's what Puffy does. It handles the orchestration. And the whole piece is Dockerized, which means I can now put it in any environment and it's uniform. And I don't need to worry about whether the setup is right or wrong because we've already codified and checked it into the repository.
Gotcha.
So let's look at live demo of this whole setup. So Puffy itself is installing it. It's practically a matter of just downloading this file and extracting it to a location of your choice. Mm-hmm. I've already done that. So I'm just going to export Puffy's home to that location. And that's all you need to install Puffy. But once you're done with that, I need some sort of a project that already has Karate API test, which I can repurpose as performance test. So for that, I'm going to take the Karate GitHub repository and they have a demo project. This is a Spring Boot application, and use their Karate feature file as a performance test. So I've cloned that repo already. I'm gonna start the application, so that's already running. So let's check if that's going already. And hello world. So the Spring Boot app is up and running. So now I need to run a performance test against it. What do I need? I need coffee.sh, and I'm going to init this project. So init adds a couple of files. One is a YAML configuration file, and another is a folder where all the related configurations of settings. So let's take a look at the first YAML file. So Perfy drops in a pre-configured YAML for you to work with, but I'm going to replace it with something that I already have, the pre-cooked for the demo. So there you go. Let me walk you through this file in a bit, but meanwhile, I'll just quickly boot up Perfy itself. So I need to start the setup. So why do I need to do this? Because the entire setup runs inside Docker. And what you will see inside Docker is practically the stack that I earlier showed on my slide. This is what is booted up inside Docker. And this guy is saying that, hey, everything is up and Grafana is on port 3000. Let's wait for that to come up. All right. Grafana is almost there.
There we go.
Right. And the default username and password is admin and admin. I'm not going to bother changing it for now.
Sure.
So let's just jump right in.
Isn't it funny how a few seconds when you're doing a demo feels like hours? It's always the
Absolutely.
way.
The demo goes,
Exactly.
Yeah, but I'm fairly confident because we've been doing this on multiple projects of late. So yeah, and Perfy has already dropped in a templatized dashboard, so to speak.
Sure.
There's no data in here. It's just a Grafana dashboard. But to populate that system data, let me kick off a test. And when I say Perfy.sh test, what it does is it takes this YAML file and starts running. So I'll kick it off. While it is in progress, I'm going to explain like what this YAML configuration itself talking about. So starting from the top, obviously the first parameter, the Karate features directory, and then the file, Karate file. These two are helping Perfy locate where my Karate API test, greeting.feature API test is sitting inside the code base. So that's the location coordinate, so to speak. Second line says Karate env. So this is required because in the Karate config.js, I have to mention how to locate the application itself.
No.
Now, Perfy is inside Docker, and the Spring Boot application is running on my local host. So for Perfy to locate it, I go through postgres.docker.internal. It could be any other URL. So I just mentioned that environment variable here. And this constitutes one scenario. You could have multiple scenarios. You can string together multiple feature files. That's practically all the top 4 lines. Right? The next one is the scenario name itself. You could change it. Just left it as it is. And the rest of the file is interesting because this is the actual load test, the load pattern description. Now, typically, if you are writing Gatling test, you have to write Scala code, like I mentioned. Even if you are re-leveraging Karate API test, you still have to write Scala code. At times I felt that was a little bit of a drag, even though I love Scala and I love the DSL syntax of Gatling. I still felt it would be nice if you could just give configurations right here. So we created parallel, DSL in YAML itself to say, hey, I just want a 60-second test wherein I do nothing for the first 15 seconds. Then I have one user, and then I have 3 users for so and so seconds. That's it. And Perfy has started reading this, compiled this whole thing into a Gatling simulation, and it's now running it as a performance test already. So if we go back to a Grafana dashboard, we start seeing some data come through. Let me quickly walk you through this. On the bottom, I just have the CPU and memory of the Perfy's performance testing stack itself, just as a way to demonstrate that I can pull information from container advisor, C-advisor, and show it on Grafana. And on the top, I have the request count, the response times, and whatnot for the test itself. And right on time, we have the data coming through. So that's practically all it took, right? It didn't take me very long to take a project that already had Karate API tests and convert them into Gatling performance tests on my machine. And I can achieve decent amount of RPS efficiency. I have what, I'm roughly doing 6 RPS, which is highly respectable for a small machine. But we could go a long way depending upon your memory configuration and whatnot. So, yeah, that's your quick demo of Perfy.
Awesome.
All right.
Cool.
So,
Perfy looks interesting.
Perfect. So, how does all this help, right? All fancy code and whatnot and software and everything. How does this help us? The overall topic of this conversation, which is the shift left field. So, to quickly recap, we have our local machine, and I have my API code and Karate test, and I deploy my application to the local environment, which could or could not be Dockerized, and that's practically my app. And I install Perfy on my local machine, and all I need to do is create a YAML configuration. And Perfy is able to make sense of this YAML configuration, take my Karate API test and run it as performance test against my deployment, pull the metrics both from my application and the Gatling itself, so that I can see side by side, so that I can correlate, with the load, what happened at a certain load, what my CPU memory was. I could do that correlation.
Yep.
And ultimately, I can see that on the dashboard and make a decision after analyzing the test results. And all this is happening on my laptop. So this is the shift left part. And once I'm happy with the fact that my code is working and performing in line with what I expect, I can promote the code to higher environment to a deployment pipeline. And likewise, I can promote my performance test setup also to a higher environment, to a first step pipeline, so to speak. And that would be the right side. Again, I'm not having to deal with any additional complexity because it's exact same stack and it's containerized, so it deploys in higher service. And the process is the same. We generate the load, we get the data, we analyze, make that process easier. And that's the whole idea behind it.
Interesting. Really interesting ideas there about how you could integrate performance testing into that pipeline, because they are two distinct things, aren't they? The deployment pipeline is almost the enabler. You've got your infrastructure as code or whatever it is. Probably deploy that on the way through to make sure does everything deploy as expected. You could feasibly, probably as well, use infrastructure as code to create an environment which is temporarily there, representative like a production environment or whatever environment, and then run those tests using something like Perfy's, Gatling, etc., to then go and get that quick insight, get rid of that environment again, and then take action based upon that to reduce that cycle again, reduce cost. It's really, really interesting as a concept. Really interesting.
Awesome. But then I think the bigger problem for me is that we can do all this technology related changes, but the biggest challenge for me to shift left is the mindset. I call it performance testing versus performance engineering, because the word testing seems to play a lot on how we perceive this whole activity, right? Because this testing, we feel like it's a verification activity and after the fact activity, but then you build everything and then ultimately you just verify, it's just checking all the boxes.
Yep.
That's probably too late. What I would instead like it to be, personally for me, I enjoy performance testing because I learn a lot from it about architecture, about applications, about systems. And I like to run it as multiple spikes, like each of them time-boxed activities from which experiments I can learn early on and make informed, proper decisions instead of guessing about architecture. It's very, I've seen quite often that many teams just, pull stuff out of thin air saying, hey, let's add Redis, let's add Kafka and it's going to perform. Yeah, sure. But going by the good old SRE saying, which is if if you haven't tested it, assume it's broken. So you cannot really guesswork is not a good idea.
Yeah.
So, I mean, any day, right? So performance testing has to become a lot more scientific and has some rigor about it.
Mhm.
So that's where imagining, can I templatize this whole thought process which we have been speaking about to sort of, even again, for all that I'm saying, many a times I'm tempted to do stuff on the right hand side. So I need a template to frame my mind and bring it back into a conscious decision. So I sort of came up with this idea. I call it continuous evolution template. And on the left hand side, I have the basics, the problem statement itself, the baseline KPI, the target KPI I need to hit, and the hypotheses I have in mind. On the right is a more interesting aspect, wherein here's where we design experiments. And I made it very clear to myself that I want a falsifiability experiment and a verifiability experiment. And ultimately, I want some validated learning out of it. So let's put some of our examples through this and see if it fits. I'll again take the beaten track of increasing the RPS with a certain CPU. I want to take from 10K RPS to 100K RPS, a tenfold increase with the same CPU. Like any good developer would say, let's throw in a cache and things should automatically become better. But that's just an assumption, right? What's the falsifiability experiment here? I would go back to the with and without piece, wherein adding the cache should make some discernible difference.
Yep.
Without which, I don't need to go to the higher environment for verifying. If this doesn't work, I won't even go to the verifiability part. And I try to analyze why this happened, and I realized my cache miss rate is 100% maybe. So I further hypothesized that miss rate is happening because the time to live on the cache keys is very low. So even though you can access the keys are expiring. So I fix my TTL, I run the same experiment again. This time I see a discernible difference. So I try testing on staging. But staging is not the same as production, right? So obviously it doesn't have as much infrastructure. But what I can do is I can use the trend analogy, right? Now I don't need the full scale testing, but I know that I just need to do 10x of what is already there. So I take the staging baseline, do a 10x of it. And can I achieve it? I'm not able to do it. And then I realize that's happening because I still have a certain miss rate and I have high eviction rate from the cache. So now I hypothesize eviction has to do something with the cache size because the cache is too small. So keys are getting pushed out. How do I test this on my local machine? I don't have as much RAM to work with. So again, the tough experiment here is if I cannot increase the memory to prove that it's better, reduces eviction rate, can I reduce the RAM available to the application and exaggerate the problem to say now eviction rate has some causality relationship between cache size and this whole two parameters. Once I prove that, then I go to staging, I retest the setup, and this time it works. So I'm able to hit 10x with whatever is the baseline at staging. Now I can go to prod replica. What I've also achieved as a byproduct is all this validated learning now is helping me, provide some suggestions as to how production itself should be set up. I can say what should be the TTL, what should be the cache size. I can sort of suggest. And again, I don't need to jump very much ahead and do full scale testing. I deploy. I see that the deployment makes a discernible difference at whatever rate is already happening. Once that works, I do a full scale test for the 100K RPM. Once that works, then I ship. So this whole template sort of forced me to think and solve the problems on the left-hand side because I always have to design a falsifiability experiment and then only confirm it on the right, which means my dependency on the higher environment went down drastically. So that's obviously this is a very simplified view. Yeah. The steps are a lot, but for the purposes of demonstrating the idea, I just thought like 3-4 lines here would sort of help put the problem and the solution forward.
I think this slide has been the favorite one of everything that you've shown here. I love the story because it just encapsulates everything that we've talked about. This idea of starting with a hypothesis, this idea of being scientific and methodical about the approach, almost using that statistical analysis approach of looking and going, right, what's the hypothesis? How do we invalidate that? How do we verify that? And then using that as your basis to iterate over, make those changes, run those experiments to reduce the need for those right-hand shifted tests, bring it all back into that controlled environment. Favorite slide, certainly, of everything we've seen. So love that. Love that. Awesome. Really, really
Glad
good.
you like that. That's practically all I had in terms of sharing what I have learned so far about shifting left and performance left. I think there's still a long way to go, even for like some of the teams I'm working with, and with Perfies as a tool, and this whole idea of shifting left. There's still stuff which we can potentially do, containerized testing and whatnot. But as said and done, I think at least if organizations and teams start thinking about this idea, the first 20% itself is a huge gain, because that's where I have a sense that many organizations are losing money, a ton of it, because they build a lot of features and go to production, and then it's both a reputation loss and then ultimately a lot of waste of money and morale, which is not to be taken lightly. To try and shift left, better peace of mind, and also, like you rightly pointed out, being scientific makes one's learning better also. After I've adopted this sort of an approach, I think every tool that I've used, a cache or any new technology that I work with, the rigor with which I learn it and understand the manual has been absolutely like, I have to have that discipline to look through it. I'll stop there. So that's probably my experience, and I hope the teams will take something away from it.
Excellent. No, thank you, Harry. Really, really awesome session there. I think there's a lot for folks who are listening in and watching to take in there, and I think those last few pieces summarized it quite well. So I don't think I have any follow-up questions at all, apart from just saying a big, big thank you for coming on. Really interesting topic. Great demo to see the tooling and how it can help with that scientific approach. So it'll be interesting to see maybe in the future how that journey continues as well, and as that space matures a little bit more and evolves over time. So great session, Harry, and thank you so much for joining.
Absolutely. Thank you very much for having me on.
So there we go, folks. We have been talking all about shifting left performance tests. What an awesome topic. What a great, great set of insights there from Harry, all around how you can be scientific and hypothesis driven with the changes that you're going to make, how you can, I guess, evolve the metrics and the boundaries of what you're looking for to suit some of those earlier environments, and how you can then build upon that to eventually shift left, test earlier in those environments, and then use those to your advantage as you get towards some of those non-production environments. So by the time you get production ready, you can be confident in the non-functional requirements that you're looking to achieve, and making sure that you're building an application for the purposes that you're setting out. So great session there. If you've liked the content, please hit like, please hit subscribe, please hit the notification bell, of course. And as always, folks, stay safe, stay healthy, and until the next session, thanks for tuning in. Bye for now.